Welcome back to Tech Circumference. If you are new here, please subscribe and join the journey of breaking down complex tech concepts into clear, relatable explanations. Before we continue, I just want to say thank you. Tech Circumference just crossed 100 subscribers. That might sound small to some, but to me, that's 100 real people who chose to learn here, and I genuinely appreciate every single one of you. We are just getting started. Without further ado, let's dive in. Have you ever wondered what really changes when a website moves from HTTP protocol to HTTPS protocol? I mean, it's just one extra letter, right? But that one letter completely changes how the data travels across the internet. Today, I'm going to explain HTTP and HTTPS along with SSL and TLS using something very simple. That's a birthday gift. Imagine you want to send a birthday gift to your friend who lives far away. You pack it, you write a message, you hand it to a courier. Now, that gift doesn't teleport. It passes through warehouses, trucks, checkpoints, and many hands before it reaches your friend. That's exactly how data travels across the internet. It hops from router to router until it reaches the server. Now, here is the real question. What happens if that gift is not protected? Sending data over plain HTTP is like shipping your birthday gift in a transparent box. Yes, it will arrive, obviously, but anyone along the way can read it, look at it, even replace what's inside. HTTP only handles delivery. It doesn't protect privacy, it doesn't verify identity, and it doesn't detect tampering. It just delivers the package. And on today's internet, that's not enough at all. So you decide to fix the problem. Instead of a transparent box, you use a locked one. Only the intended recipient can unlock it. And if someone tries to tamper with it during delivery, the damage is immediately detectable. That's what TLS does. TLS, Transport Layer Security, adds encryption to your connection. It gives you three things: confidentiality, integrity, and authentication. Now, your message is private, protected, and verified. Now, you might be wondering, if TLS is the lock, what was SSL then? So here is what SSL is. SSL was the original version of this security system created in the 90s, but it had serious weakness, outdated cryptography, design flaws, and security vulnerabilities. So it was replaced by TLS. Today, when someone says SSL certificate, they almost always mean TLS. SSL is obsolete, TLS is the modern standard. So here we go with the most important idea in this whole video. HTTPS is not a different protocol. It is just HTTP running over a TLS secured connection. Before any website sends data, first the TLS handshake happens, the certificate is verified, keys are exchanged, a secure tunnel is created. Only then HTTP does send the actual request. So when you see HTTPS, you are still sending the same message. It is just traveling inside a logged, encrypted tunnel. But locking the box is not enough. You also need to verify who you are sending it to. That's where certificates come in. A TLS certificate is like an official ID. It proves the domain name, the server's public key, that a trusted authority signed it. If that certificate is expired or invalid, your browser warns you. Because encryption without identity verification is not real security. Only the server proves its identity. But in high security systems, both sides verify each other. That's called Mutual TLS, mTLS. It's used in microservices, zero trust networks, secure APIs. It's not just a locked box anymore. It's a verified exchange between trusted identities. All right. Now that we have broken everything down, let's zoom out. What you are seeing at the top is the simple version, the human analogy. You, the client, sending a gift. It travels through roads, networks, public Wi Fi, but because it's locked with TLS, nobody in the middle can peek or tamper with it. Only the server on the other side has the key. But here is what really happening under the hood. Your browser opens a secure HTTPS connection. It verifies the server certificate. That certificate is signed by a trusted certificate authority. Then TLS creates an encrypted tunnel. Inside that tunnel, HTTP messages travel safely over TCP. So HTTPS is not a different internet. It is HTTP wrapped in TLS running over TCP. And lock icon in your browser, that's the exact proof the whole system worked. So that's the complete journey. Two common questions. Is HTTPS slower? Not really. Modern TLS is extremely fast. Does HTTPS mean a website is safe? No, it protects the connection, not the content. Can a site be secure without HTTPS? No, not at all. Data can still be intercepted. What happens if a certificate expires? Browsers block access or show warnings. So if this has helped, I will see you in the next one. Thank you for watching.